Today I will demonstrate the effect of dissolving a static mesh using the Niagara plugin. The main feature will be a way to reconstruct the color of the static mesh material without creating special materials for particles. As you can see, in this demo each item on the stage with random material and particles repeat the color. In the first we need to create a project version 4.25.3. Open the launcher, start creating the project. This will be game project. Our project will be based on the first person template with starter content. Let's play the project and make sure everything works. Before we start, we will spread different static meshes on the map. We will also assign them random materials. Now let's start creating the effect. Create the folder Niagara VFX. In it we will place our actor and the particle systems and different materials for our system. In this example, we fire projectile actors that have an event code after hitting the static mesh. Our effect will look like this. Projectile actor gets into a static mesh, it takes a reference to it and spawn our effect actor, which is post a reference to the static mesh actor. The effect actor starts a system of particles inside itself. When effect finished, our actor and static mesh will be destroyed. Creating an actor that will be responsible for the effect, and let's name it Dissolver. This actor will add the Niagara particle system and transmit all the necessary information to it. We will need to pass it a link to the static mesh when spawning, add the source variable and enable expose to spawn. Add a spawn dissolver actor to the projectile. It will have the same transform as static mesh, passing the target from the hit event. The check for begin play add print string in it. But there is a problem that multiple hits create many dissolver actors with the same link. Add the dissolve tag and check if the actor has this tag when it hits. After the spawn, we need to attach the dissolver so that the effect is always next to static mesh for the correct display of the effect. It won't because I plan to use GPU simulation in Niagara system. Finally, let's start creating a particle system. We use the directional burst example emitter as a basis. Next, remove the extra modules and change the sprite orientation settings. Disable all parameters that will be calculated in the new module. Sprite size as random, float. change spawn burst to spawn rate. Switch to GPU sims and fix bound. We will create a simple model so we can use ScratchPad. The input parameters are static mesh and strength for velocity. We need to calculate the position and normal from static mesh component for calculate position of particles and velocity of particles. Also, we will use the velocity strength parameter to adjust the velocity of particles. Then apply our model and add this model in particle spawn block. Also, we create user parameter static mesh because we can add this parameter from blueprint from our source actor. Bind this parameter in static mesh source model and change velocity strength to random in range. Before starting the system test, we need to pre-calculate the static mesh components that we have on the stage by selecting them in the preview in user parameter. Find our meshes on the map and turn through them in the preview block and click Fixed. Our system is working, now you need to add it in our actor. We will put it all on begin play. Get static mesh component from our source actor. Check component is valid. Next, call add Niagara particle system and choose our system, dissolve Niagara system. Next, we can set our static mesh in our system from blueprint. Call function set static mesh component, set Niagara static mesh component. We can add name from our Niagara system. Next, we can assign to particle system finished, because we can destroy our actor and static mesh source actor when particle system will be finished. As we can see, our particle system reconstruct position and normal of our source actor static mesh component, but also we will use color of material of our static mesh. In first, change materials of our actors on the map on different materials from engine content or starter content. On ScratchPad in our model, in input parameters add texture sample. We will draw in this texture sample material from our static mesh components and get this texture sample from blueprint. Sample texture in Scratch model in color from UV and change alpha in this color to 1. Also add texture parameter in users parameters, because we can set this from blueprint. In Blueprint, we can call create render target and draw material from StaticMesh component in this render target, and then set texture parameter in our particle system to this render target. We can change after activate parameter in our particle system to false, and after we set all parameters in Blueprint, we can to activate and reset our system. As we can see, calling the drawMaterial to render target function helps us reproduce the material color for our particle system. There are many disadvantages, but this is more or less universal approach to this effect. I tried to create an effect that would help with a minimal amount of customization of the particle material to destroy the static mesh on the stage with color. Also, we can add collision model in our particle system. If we add new static mesh from starter content, then before dissolving them we need to make a fix in the particle system by moving our mesh there. As we will see later, we can create different ways to use the received information from the static mesh material. Thank you very much for watching. This is my first lesson with voice comments. I'm waiting for the feedback. Thank you. Bye.